The Research and Development Center of MAKROchem is located in Chruściel in northeastern Poland, in a logistic complex of the company. It constitutes the initial phase of MAKROchem's strategy to close the cycle on over 2 million metric tons of carbon black it sold during the first 25 years of operations. As this amount of raw material was used to produce 1 billion of tires, MAKROchem now aims to process them back by setting up pyrolytic installations next to transloading bases in Poland, Spain and the United States, and at carbon black producing plants in Russia and the Ukraine. In order to secure quality control and compliance with carbon black type, we perform the basic tests of iodine number, NSA, STSA surface tests. Those parameters are connected with the size of the primary particles of carbon black and they shape its activity. The activity of carbon black improves the physical and mechanical properties of rubber. The next step is to estimate the oil absorption number. This parameter defines the so-called structure of carbon black, that is, complexity of aggregates. Increasing the value of the structure improves the important properties of the rubber. Next, we measure other values important in the production of rubber composites. One of them is the pH level of water-based dispersion. It describes the bulk of acid groups of carbon black, which will significantly influence the speed of vulcanization of rubber compounds. As commercially available carbon black is pelletized, we measure pellet hardness. If those values are in proper range, transportation and seamless work of industrial installations is secured. Particle size distribution is an important parameter, especially in case of recovered carbon black. The measurement is conducted according to a proprietary method of the R&D Center, and the result describes dispersion capability in rubber compound. Subsequently, we evaluate the level of impurities in carbon black. First and foremost, moisture content. This is an important parameter. If the value is too high, proper rubber compound will be difficult to obtain and vulcanize. Especially in the case of recovered carbon black, volatile content and ash content are of extreme importance. If those values are too high, the allowed limit of polycyclic aromatic hydrocarbons in the compound will be exceeded and the characteristics will deteriorate. We perform more detailed analysis of composition of carbon blacks with measurement of elemental volumes such as carbon, hydrogen, nitrogen, sulfur and oxygen. In this method, we burn the sample and analyze the resulting oxides. The next test of content of carbon black and its morphology consists of imaging and scanning of elements using SEM-EDX technique. This measurement allows us to observe the size of carbon black particles, composition of aggregates, and the size of grain of carbon black in free form and in rubber composites. EDX allows us to perform quantitative and qualitative analysis of elemental composition of carbon black. We analyze the impact of carbon blacks on the production of rubber compounds in lab Banbury-type mixer and two-roller mill. Using rheometer, we estimate the kinetics of vulcanization of rubber compound, the value of torsional moment as function of time in given temperature. Based on this, we estimate, among others, scorch time and optimum curing time of rubber compound. A properly prepared rubber compound is placed in a vulcanization mold and pressed in specific temperature and time period based on optimum curing time. In this way, we produce samples of vulcanizite that we test further for physical and mechanical properties. Firstly, we measure the hardness in Shore scale, as it is one of the basic parameters of rubber. It defines it and allows to evaluate the correctness of production processes. Secondly, using a tensile testing machine, we estimate durability. Tensile strength at break, strain at 100%, 200% and 300% elongation, elongation at break and tear resistance. Durability parameters indicate the quality of the compound and are used in further engineering calculations. An important characteristic of rubber is its abrasion resistance. In our R&D center, we use a rotating drum and measure the loss of volume of the sample subject to an abradant on specified distance, time and pressure. Another feature of rubber compound that we measure is flexibility of the vulcanizite using Schob method. It is one of the methods evaluating viscoelastic properties important in dynamic applications of rubber. Using optical and scanning microscopy, we test the morphology of rubber, to evaluate macro dispersion of the filler. At a specified magnification, an image of the cross-section surface is recorded and dispersion ratio calculated in percentage points.